Hi guys, Mrs. Delisin here. Welcome to another lesson of AP Statistics. Today's lesson is confidence interval for a mean difference. Please note that this is a different lesson than, the previous lesson we had confidence interval for a difference in means. Yeah, that's different. Like, how is it different from this lesson? So hopefully you will see that one as we go through this entire lesson. This memory training help, you will be given a list of words and then you'll be given 3 minutes to memorize as many as possible by just rereading the words. You'll record as many words as you can remember. And then you will be given another list of words to memorize for 3 minutes, but this time using a memorization strategy. You will record as many words as you can remember. The first strategy is rereading. You're just rereading the words over and over for 3 minutes. The second strategy is using the words in the story. And then we want to compare how many words you memorized by reading the story and versus how many words you memorize by a strategy of rereading the words. Okay, for the purpose of, because we're all of again virtual and some of you are out there, we're in different location, I'm going to be using the data that I have from last year. Over here on my strategy 1, I have a student who scored 12 and the same student scored 14, meaning, let me highlight the first example. So this is one student where he memorized 12 words using strategy 1 and then memorized 14 words using strategy 2. This 10, 11 is another student who memorized 10 words strategy 1 and then 11 words using strategy 2. So it looks like a lot of students memorize more words using strategy 2, right? Using the story. But not all, of course. Some students memorize more words in strategy 1 than in strategy 2. Like, say, for example, who's the example? Like this kid right here, right? More words in strategy 1 than in 2. And this kid. Okay, on this kid memorized same words in strategy 1 and strategy 2. What we're going to do today is we are going to calculate the difference in each pair, right? Calculate the difference in each pair. So we are going to subtract 12 and 14. And we want to make sure that we know how to subtract. We are going to subtract it as S2 minus S1. So strategy 2 minus strategy 1. So that is 14 minus 12. 5. Oh, I use a different color. Red is for emphasis. So 2, 1, 5, 0, 3. I'm just subtracting each numbers, you guys. No biggie. 9 minus 8 is 1. 4. Of course, please pause the video while copying all of these numbers. And then 10 minus 8, that's 2, negative 2, 4, 3, 2, negative 2, 3, 5, and 0. Okay, so I have how many zeros? I have 3 zeros, yeah? 3 students who memorized the same amount of words from strategy 1 and strategy 2. Now, we are going to make a dot plot of the differences. So, I'm going to focus on my blue numbers. Okay, I'm going to make a dot plot combining all of my differences, all the blue. Okay, and here's the dot plot. So, I have this 2 is right here. That's right there. That's right there. That's right there. That's right there. And I think you guys kind of know what I'm trying to do. Yeah? So let us, number 5, what does the dot plot suggest about the memory training? Let's analyze what our dot plot tells. This 0 means no difference, right? There's no difference between strategy 1. Oh, what is that? There is no difference strategy 1 and strategy 2. Over here on the positive section, strategy 2 is better. And then on the negative section means strategy 1 is better. There you go. So, there are, oh, by the way, there are 27 numbers. We have 27 pairs, right, of numbers, meaning I did have 27 students that joined the study or the experiment. So I have, my N is 27. Okay, what does the dot plus suggest about memory training? It looks like we have more dots on the strategy 2 is better side. Okay, and how many is that? There's 27 dots. 1, 2, 3, 4, 5, 6, 7. So we have 7 in the negative, from 0 to negative, and then we have 20 then. Yeah, 20 out of 27 students. So 20 out of 27 students remembered more words using strategy 2. Okay, and then I just put all of these numbers. I put all of the blue numbers in the Staplet.com or in the calculator. If you put it on the calculator, you go to one variable statistics. If you do that, you should get your mean and your standard deviation. So my mean is 2.07, standard deviation of 2.51. By the way, the notation for this is X bar diff because we want the difference between each pair, and then S diff because I want the standard deviation of each pair. So let us interpret on average, right? That's how we always do our mean, right? On average, a student remembers 2.7 more words using strategy 2. There you go. So I'm hoping that you see the difference between this lesson and the previous lesson called difference in means, because in that lesson we have two different groups of people. Like we have all adults, all children, or all 15 and older, a 15 to 19 group, and then the group of 75, or adults between children, women versus men. We also had juniors versus seniors. Like we always have two different groups, two different means, two different standard deviation. But in here, we only have one mean and one standard deviation because we've subtracted them each pair already. Okay, I hope you are seeing the difference between the two lessons. Okay. Construct a 95% confidence interval for the true mean difference in words remembered by students using strategy rather than rereading. State the parameter you want to estimate and, of course, your confidence level. So, my parameter is mean difference. Okay, please take note of the difference. You have true mean. There. True mean of the difference in words to remember. And then we have it at 95% confidence level. My statistic is X bar diff is 2.07. That was already, we got that one from putting either into Staplet or putting all our numbers into the calculator. Okay, What else? The name is going to be different. The name of the procedure is one sample T interval for mean difference. My condition, same thing, random. This one is order of treatments is randomized. This is so that we can show causation. Right? And how do we know it was randomly assigned? There you go. Let's go back. Right? In here, we have to look here. We have to assume that we randomize the order of treatment is randomized, meaning like this group of students gets randomly, they get either the memorization first, like the rereading first, and then the what's the other called? The rereading first, and then the other one is doing it in a story. Or some students do it the other way around. Okay? So the order of the treatment is randomized. Because we don't want to just give all of the students all at once, all at the same time, all at the same group, right? All of them. Like we have to make sure that the order of the strategy 1 and strategy 2 is given to them randomly. Okay, 10% condition. 10% condition, in this case, is not needed because you randomized it already, right? There was no random sample going on in here. So let me put that in red. No random sample. Okay. Next, for normal, we don't use we don't use large count in here, okay? Because this is not proportion, this is means. Now, let's go back. The population didn't say that it was normal. And CLT can't be used either because our N is not greater than 30. It's not greater than or equal to 30. Our N is only 27. So we cannot say it's normal because the population is normal. That's not applicable. We cannot say CLT, central limit theorem, because our N is not greater than or equal to 30. But we can look at our dot plot. Our dot plot seems to be no outlier, seems to be no skewness, right? And so even though our N is less than 30, we say it's normal because the dot plot of differences shows no strong skew or outliers. So the sampling distribution is approximately normal. There you go. Okay, general formula. We're so used to this one. Point estimate plus and minus margin error. Our standard deviation, our formula is not going to be x bar 1 minus x bar 2, okay? It's going to be x bar diff. So whatever the difference between each pair, plus and minus t star, same thing, and s diff over square root of n. So x diff is 2.07, right? We got that from Staplet or we got that from the calculator. Plus and minus my df in here, 27 minus 1 is equal to 26. So my df is 26 at, what's my, let me go back, 95% confidence. At 95% confidence, so my t star is 2.05 6. Please, verify. Don't just believe me on it. You need to make sure that you're actually looking on your own. My standard deviation is 2.51 over the square root of n, which is 27. 2.07 plus and minus 0.99. And then all I have to do is add and subtract that. 1.08, 3.07. Okay, there you have it. I have my answer. So, I have my conclusion all the way. I can just put the conclusion here. So, we are 95% confident that the interval from 1.08 to 3.07 words, you need to make sure you put your label. If it's minutes, it's minutes. If it's words, it's words. Captures the true mean difference, not the true difference in means, okay? True mean difference in words. Remembered using story over rereading. Okay, there you have it. And then we are going to have our number 6. What's the question here? Do we have a convincing evidence that there is more words remembered using a story instead of rereading? Do we have a convincing evidence that there is a difference between the number of words kids remembered using story and rereading? Of course, we have that evidence because both of our interval, they're both positive. So, yes, all of the plausible values from the interval are positive. Okay? Or technically, 0 is not contained in our interval. Okay? So, here you go. Our important idea section. What did we learn today? We've learned distribution of differences. We learned like the dot plot kanya. So in the middle, this means no difference. And then this means that there's a positive difference, positive diff. And then this one on the other side is negative diff, negative difference. Okay. And then what else? Our statistics in here, they're named as X-bar diff and standard deviation diff, the standard deviation of the difference. Okay, what else? What else did we learn? And this is confidence. It's called confidence interval for paired data. When you say paired data, do you remember this from chapter 4? Do you remember this from chapter 4 where the subject is given 2 treatments? We call this the match pair. A subject is given 2 treatments. Like if they're trying to compare which one is better, this bottle Coke or this bottle of Pepsi, without knowing which one is in it, right? And so we have to give it to the subjects. We cannot just give, okay, this group gets Coke and then this group gets Pepsi, and then you're gonna compare. You cannot do that on this case, right? You have to give both treatments. And this is what we're doing in here. Whenever we have to give both of the treatments to each subject, we call this one the confidence interval for paired data. So the name of it We'll now change into one sample, t interval for mu diff. And then our formula is x diff plus and minus t star s diff over square root of n. Okay? Here you go. Let's start with this one. Teenagers spend on average approximately 5 hours online every day. Kind of sad. Do parents realize how many hours their children are spending online? A family psychologist conducted a study to find out. A random sample of 10 teenagers were selected. Each teenager was given a Chromebook and a free internet for 6 months. During this time, their internet usage was measured in hours per day. At the end of the 6 months, the parents of each teenager were asked how many hours per day they think their child spent online during this time frame. Here are the results. Okay, we have teenager, we're just numbering the teenager. Teenager 1, 2, 3, 4, all the way to 10. Actual time spent online is the first row. And then the second row, actually the third, but the second row is the parent perception, like how many hours the parents think their kids spend online. And then I have a difference between the two, which is A minus P, meaning the actual time minus the parent perception time. Okay, make a dot plot, A minus P in time spent online hours per day for each teenager, and what does the dot plot reveal? So let's put that in. Okay. What should our title be in here? 0, 1, 2, 3, 4, 5. Is 5 the highest? Yep, 5 is the highest. And then we have the title, difference A minus P. Okay, so let's start. I think I should have that. I should have it more. Hold on, because you know how I have like 5.9 and stuff. Let's put it like distance. 0, 1, 2, 3, 4, 5. There. Okay. I'll start with 3.4. That's 3.4. 3. I'll just do that there. I made a point there. And then I have 1.7 around this area. 4.7. 4.9, 1.8. What is this one? 1.7, 1.8, 0.9, and then 4.1, 2.7, all the way here, 2.8. There you go. All right, is this 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there you go. We have, they're all positive. They're all above 0. We don't have a negative difference. Okay, so find the mean and the standard deviation of the difference A minus P in time spent online. Interpret the mean difference in context. So if I put all of these numbers in my calculator and go to one variable, statistics, I'll get my mean and my standard deviation. Or I can put all of them in the Staplet and I should get my mean and my standard deviation right away. In this case, my mean difference is 3.02. My standard deviation difference is 1.32. Please, you guys, I didn't do that by hand, and I taught you guys already how to put those in the calculator to find the mean and the standard deviation. We don't want to do anything by hand. We don't want to add everything and divide them by 10. It's going to take us so long. The amount of actual time spent online was 3.2 hours longer than what parents thought. I think I forgot the word. I'll just insert that in there. On average, there. The amount of actual time spent online was 3.02 hours longer than what parents thought. Okay, there you go. What do we have here? Construct and interpret. 90%. So we're gonna do all of this state, plan, do, and conclude thing. Let's start with stating the problem. So state the problem. We have mu diff is the true mean difference in time spent online, and then I subtracted that a minus b, and then my x diff is 3.02, my s diff is 1.32. What else? My confidence level is 90%, and that's it. Let's go with plan. Plan is one sample t interval for mu diff. And then I have, was it random? So random sample of 10 teenagers. I have to check 10% condition in here because this was not randomly assigned. There was no randomization going on in here. So, and there was a sample that was done. So I have to do my 10% condition. 10 is less than 1/10 of all teenagers. And then for normal, the population wasn't say that it was normal. Our n is less than 30. So we have to check if our dot plot has skewness or outliers. It looks like it doesn't have one. So the dot plot of differences, so that's why the dot plot is needed if our sample is really small. The dot plot of differences has no strong skew or outliers. Okay, what else? Let me solve that. I'm not gonna put all this specific formula, general formula. I'm not gonna put any of those. I'm just gonna, of course, I'll just put specific. I'm not gonna put my general formula and all of those. Diff over square root of n. So 3.02 plus and minus df of 10 minus 1, so that's a 9. So a df of 9 at 90%. So let's check that. Okay, I have my df of 9 and then a 90%. That's 1.833. Okay, 1.90%. Yep, 1.8333. So 1.833. So T star of 1.833. And then 1.32 divided by square root of 10. Of course, I always have to do my margin of error first. And then I will just combine them by subtracting and adding. Okay, so what is 1.833 times 1.32 over square root of 10? All right, I think that is 0. I'm going to round it, okay? 77. So 3.02 minus 0.77, 2.25 Oh, hello. Comma 3.02 plus 0.77 is 3.79. Please don't just believe me that it's 0.77. Make sure you also check it in your calculator. So, conclusion, we are 90% confident that the interval from 2.25 to 3.79 hours captures the true mean difference A minus B in time spent online by students. Okay, there you have it. I hope that you'll be able to answer your homework after watching this video. If you have any questions, please let me know. And please make sure that you know the difference between confidence interval in difference of means and then confidence interval in mean difference. Okay? Thank you guys. I'll see you guys on the next video. Bye!